Number two, I don't think people had problems with. Maybe I'll go to a different version. So if you wanted more problems, by the way, I loaded up a ton of problems on WebAssign for extra practice. But if you want more problems, you can also practice the other versions of the quizzes that you didn't take. There's 4 different versions of the quizzes. Just a reminder, remember the cell phone rule. So here's an example. They're all pretty similar, and like I said, most of our 2 sections did well on this. The inner is the inside stuff. The outer is square root of, you cover up the inner with your thumb. You replace your thumb with an x to get x to the 1/2. Derivative of the outer function, I don't think anyone got that wrong out of those sections. Derivative of the outer function is 1/2 x to the minus 1/2. And then you assemble the derivative of the outer function with the inner plugged in for x times the derivative of the inner function. So pretty pleased that most of our students got it right. You know what this means? Calc 1, it's not just bio students, it's the molecular bio students, chemistry students, physics students, and math students. We outperformed them. Who rules? Bio students. And tangent line, everybody seems to be able to do this part. Thank goodness. It would be depressing to me if we couldn't do this. You do y minus y1 equals m times x minus x1, and you weren't even bothered with putting in stuff into the square roots. You just plugged it in and got the thing right. What was wonderful is one student, I don't remember which section it was out of, looked at the tangent line. They'd made some kind of arithmetic error somewhere, and they graphed their tangent line on their calculator with the original curve and said, something's wrong. And they wrote it on their tests or their quiz, so something's wrong. I gave them credit. So, I mean, you should be doing that all the time. If you have time on the quiz, you should be doing that. Just check your work. It takes 2 seconds to graph it and see if it looks the way it's supposed to look. You know how to do that now. And so whoever that student was, they caught an error. And that leads me to believe that in some other scenario, not in this class, maybe they're sitting by themselves. Do I have to separate people? We got chatties today. You know what? It does actually make a difference. You know, I watch students, the ones that are paying attention to me in class, they're the ones getting the hundreds every single time. So all it does is takes a little bit of attention in here, and the reward you get is 100 for it. So it's important. And students who miss class and then watch the videos suffer. So there's something about being in class and paying attention that's, maybe it's body language or something. I can't put my finger on it, because why isn't the content the same that you see online? It's somehow something's different. Okay, so this one we're going to go over right now, how to do the tangent lines and look at them and see where they're wrong or right, and why they're wrong. So there's 2 grades of information. One is I can look at something like this and say it's wrong right away, because it's not approximating the curve anywhere. Question? Oh, a tangent line one? Yes. There's different versions. Do you have the same version? This is section 3, version 1. Oh, if you had a minor error, I didn't mark anything wrong on yours, right? So if there's some minor arithmetic error, all right, we'll check it after. 5 plus 3 is 8. Is that what it is? Is it an adding error? Negative 5? No. Well, we'll talk after. So this one, I can see 2 things from this one right away. One is, you know, I call it like, how quickly can you grade? So if someone drew a tangent line like this, I know right away they are wrong, because it's not approximating the curve anywhere. So this is incorrect off the bat. So that's one level of information. The second is, where did you make the error? And that is what the student used on their test. They're like, oh, I made an error somewhere on the slope. I know I did, because my tangent lines go in the wrong direction. So we're going to do a little bit of practice with that in here today. It's the videos that makes my computer slow. Because so what you're looking at is a tangent line drawn by a student. It may be you, it may not be you. Just a student at x equals 1. Work in groups. And I think we have to make this full screen like this, and then you can see it. It's hard to see. You might want to move up closer. There's probably nothing I can do about this. And then select one of these answers. We're going to poll everybody. Work in your groups, though. So there shouldn't be 30 answers in here. There should be just how many groups we have in groups of 3. So your group will submit an answer. You need someone to blame if they're wrong. So work in groups. Sue gets up and walks back to the back again. Forget this. You can use your computers. There's a problem on here where you need a group of 3 because you're actually going to write it out. So get in your groups of 3 and start working. The faster you finish it, the faster you get out of class. The faster you can get to your revisions that you need to do on your in-class assignment. What? I'm going to post this in-class assignment, so you might not need to write this down, but the last copy will be right. Okay. Do you have a group? You guys get to work in a group of 2. You guys get to work in a group of 2. Let's see, you get to better. If you guys do better, without him here, what does that say? One way, I mean, you can't see on it in yet. So do we have everybody? I don't think we have everybody yet. How many of you guys need more time to decide? You guys need more time to decide? You decided? You guys decided back there? Jennifer, you guys group? Okay, everybody decided one? So we had a lot of students in the morning that selected the first choice. Why is that? It's actually not correct. The first choice is not correct. Number 3 is correct, that this tangent line is indeed correct. I have a student who explained what a tangent line means to her, and she did such a beautiful explanation. I had her record it in the morning class, and I'm going to post it because it's better than what I could have said. But one way is that you're trying to approximate the curve by a line right at x equals 1. So you're magnifying right around x equals 1, and it's purple there. You can't see it because it's shaded yellow. Everything has that tinge to it. But in the other class, we could actually see it was purple. And because they're covering each other, the red and blue line cover each other right there. The fact that it crosses at -2, irrelevant. -2 is far away. It has nothing to do with the approximation right around 1. And what the student said this morning is there's going to be a different tangent line depending on which point you choose. If I had chosen -2 as my point, my tangent line would have looked like this. Right? It would have looked different. So every single point has a different tangent line. And this is the tangent line for that point. And that's the only one I care about. She called it the surface. It has to be the surface of that curve. It does look kind of like a surface for the curve. And so the tangent line is correct. Some of you thought it had incorrect slope. Was there a reason why you thought that? What would it look like if it had incorrect slope? It might be going the other way, like something like this has incorrect slope. What if it was like this? Same way, but just slightly to the left. That also would be incorrect because it has to be one with the curve. So it might slice through that point in some way, but it won't be, the curve and the line have to look like the same thing right around if you took a magnifying glass to it. And that's what you should see. All right, let's try another one. Same thing, tangent line at x equals 1. Same questions.
Are we supposed to be writing?
I'm going to post this in-class assignment so you can go back and look at it, and I'm recording. So you'll have a record of it, but the very last problem you'll have to write and turn in.